Breaking the gray.
Sarah, how are you?
Very good, Russ. Very good.
You're looking very red today. I feel like your entire world is colored and vibrant in the color red today.
Well, to me, everything is orange because I have my blue blockers on.
So
Uh,
everything's orange. Oh, okay. Yes.
Everything is orange, but yeah, it's cool. I mean, I do have blue blockers, and I usually wear them. I just don't usually wear them on the show because
Yeah.
they make you look a bit of a geek,
Yeah. You're looking at a music producer. Like, hey, what do you got? What are you dropping on Friday? Like, I'm ready to ask what your new hits are.
dude. Well, I'm stepping it up. I'm stepping up the light environment motif. So I'm doing my sunrise, and I thought, okay, well, I do normally wear blue blockers, if I'm out and about. So I'm wearing them now because I've got this horrible light here. So
Well, Sarah, we are in the middle of our fourth season here in our commitment to understanding longevity, talking to the experts in the anti aging space. And one of the most important parts of this is understanding our epigenetic age and score. And I have no idea what that means. We have an expert here to tell us what that means. Hannah Went, how are you?
I'm great, Russ. Thanks for having me. I'm excited to chat with you and Sarah.
Well, thanks for being on. So, Hannah, I'm coming at this from a very novice perspective, and I did look at my score, peek at it. What is an epigenetic score? How does it all work, and why is it important?
Yeah, so I'll take a step back and tell you how this testing got really popularized. Right, it started with this idea of quantifying your aging process, your biological age. So that is really this idea that we're aging at a cellular level, which is going to be different than our chronological age. Right, the number of years you physically have lived on this earth, because sometimes we could be aging biologically maybe a little bit quicker or maybe a little bit slower. Now, when you bring it back to how you can actually perform these tests, it's been shown, according to the literature and research, that epigenetic methylation testing does look to be, the most precise, accurate, sensitive type of way to interpret your biological age. So, epigenetic methylation, that word can sound scary to novice, but it really just means that we're measuring the expression levels of your genes. So think of them like light switches, what's being turned on and your genetic information and what's being turned off.
yeah, for sure. I mean, it's very cool science and relatively new. People are starting to understand the importance of epigenetics because, it kind of puts the emphasis back on the environment rather than on what somebody's actually born with, is my understanding.
Definitely, Sarah. And I think that's such a great point as well, right? This is so exciting for people. It's this huge buzzword. It's really trendy right now because we're in control, right? You hear those phrases that's like you are what you eat, your DNA is not your destiny, food is medicine. And those statements are actually true, as cliche as they may be.
Great. And there's a lot of stuff actually in the news right now. I'm following along with God, I've forgotten his name. What's the guy from Colonel? Brian
Yeah, Brian
Johnson.
Johnson.
Brian Johnson, and also the other guy, Dr. Mark Hyman, who are looking at, aging backwards and looking at their I suspect they're looking at one of the markers they're using is their epigenetic age versus their chronological age. That's one of the ways that they're kind of making these claims in the paper that, I'm now, I think Brian Johnson is now 37 with his epigenetic age, and I'm not sure about Dr. Mark Hyman, but he's got the skin of an 18-year-old apparently.
Yeah,
Brian
yeah.
Johnson.
He's got the skin of an 18-year-old and the body of a 30-year-old, and I think he's 65 or 60 something. So
He's not 60
you're
something,
fired
right?
too. I don't know how to turn this skin around. That's a whole other discussion.
That's a whole other discussion, but we're getting there. So,
We are.
so, the, so Hannah, have you done? Russ and I have got a combined age of 100. So Russ is 51 and I'm 49. So
Okay.
we're looking now to kind of reverse the clock and start going backwards because we've spent a lot of time talking to biohackers, looking at biohacks, and now we want to try and put all of that into practice and see if we can move the needle a little bit on this aging process. So we've done the TruDiagnostic test. Both Russ and I have done it to give ourselves a baseline, along with some other things we're doing, all kinds of other metrics. We've got Aura rings, we've got all kinds of measuring devices. But what we really want to do is look at the TruDiagnostic test before and after to kind of gauge whether any of these biohacks do actually help you reverse those markers. So it would be good to go through with you, what are the main markers that you use? How reliable are they? When people are kind of putting this out in the press, is that credible data that they're using, or, is it just kind of uh, spin?
Yeah, yeah, definitely. And one way that really people, I would say, the most popular way people are really using this testing is an objective way to quantify their aging process, right? I always say epigenetics is way more than just biological age testing. It's, even expected to overtake your conventional blood testing or your hormone panel testing in the next decade. But right now, it's super popularized in aging. And you bring up a good point. There's all of these companies creating these different biological age predictors, right? So, you want to make sure, like we discussed, it's looking at epigenetic methylation information. And if it is, you also want to make sure that that company is using published, validated algorithms in the literature, right? We often joke, but are also completely serious when saying if they're not published or validated algorithms, it is like going to a fortune teller and asking, what's my biological age, and just having to trust them because that's all you're going by, right? So I think that's a huge kind of checkpoint in determining, is this an okay biological age test or not? And of course, as you both know, since you took the test, we do use a blood sample, just a little finger prick, but those lancets aren't the easiest sometimes. They can leave your finger a little bit sore.
I messed mine up. I will admit. I took me a couple of fingers. So hopefully the finger doesn't matter. I had to switch over to my other index finger because I did make a little mistake the first time, but that's okay.
And that's okay. Yeah, as long as it's a blood sample, it can be a venous puncture. We don't care where it's coming from, just because, again, all of the published algorithms that have been created have been done in blood. So you want to be, aware of companies maybe using saliva or buccal swabs, just because the cell type in those samples can vary, extremely. So they can be very different.
And it wasn't like a vial of blood or anything, was it? Or maybe I'm thinking of a different test. It was just where you use a little patch, a cardboard patch. Because
Yeah,
I've done the
low
vial
blood
ones, and
spot
they're pretty hardcore, especially with my low blood pressure. I had my sister, who's a nurse, doing all my fingers and toes at one point for some of these tests that we've done. But I think for this one, it's just as simple like a cardboard pad, right? And you just have to.
You have to let it drip. Don't tap, right? You have to let it
That's
drip.
right. You let it drip. Yeah, you let it
Yeah.
drip. You get a little sample, you send it off. So from regards to actually the sampling's pretty easy.
Yeah, we used to do a mini EDTA tube where you would prick your finger and try and drip it in the tube, but we validated that blood spot card in our lab. It works, way better than that with smaller EDTA tube. But yeah, just making sure, it's saturated throughout the back, and but you send that sample in, we can get results to you in about 2 to 3 weeks turnaround.
Cool. So maybe we can go through some of the results then that you can get from this test, and, maybe if you can, like some of the science behind it, and how much we can rely on these tests, and which is the one actually would be good to measure throughout our kind of 6-month trial. Because actually it's quite comprehensive. So maybe you can tell us, what is the most important metric to look at out of all of the results that you get?
Yeah, so excited to go over these results with you. I would say by far the most important is gonna be that Dunedin pace algorithm. It's my favorite to chat about, but, it's more of that, how quickly are you aging at this very moment? So it's giving you the validation if what you're doing is working or, may need some additional work.
What we're looking at then is how quickly you age, and it's a number, so you're looking at 1 is a one-to-one aging, and then less than 1 is you're aging slower than your chronological age, or if it's more than 1, you're aging quicker than you should be.
Yeah, exactly right, and to give a little bit more background about this one and why I would say it's the most important to look at. This is an algorithm we licensed from Duke and Columbia University. They took about 1,000 New Zealanders from Dunedin. That's why it's called that weird, funky name. They started measuring them in 1972 and 1973 when they were born. And they have followed them over 5 decades up until now. They're 52 years old. So Dr. Terry Moffat and actually her partner, Dr. Caspi, run this cohort. They just flew back to Dunedin last time I spoke with her, around Christmas time, and they're going back and taking another round of metrics. So they'll keep updating this algorithm and make it that much better as they follow this cohort around. The following years. And birth cohorts aren't unique. I want to make that very clear. But what's super unique about this study is they have a 96% retention rate. And that is just insane. You know, if you're lucky if you have a 60% retention rate, because people just, aren't super involved anymore in science, which is a little sad. And what you all are helping with, hopefully, changing that paradigm.
Cool. So we've I think we've got fairly good results. We've got um 0.81 and 0.96. So both of us are aging slower
Yeah, yeah,
than
that's great. So you're
so
aging, yeah.
slower than someone. Is this like for our age and sex, or how does that work?
Yeah, so if you look at those little graphs, we're actually comparing you to the population in the report. So you want to be under that average trend line. And if you are, that's great because who we're comparing you to is everyone that's taken a true diagnostic test. And that's going to be about 20,000 people who I would say are the best of the best, right? They're really healthy. They're seeing longevity healthcare providers in the regenerative, functional, preventative type of space. So if you're under that average trend line, that's super impressive. But I like to just be at least under like 0.98. You really want to be below one though.
Cool. So we're both under that average line. We're both under one. What would be kind of exemplary for where we're at if we're kind of looking to set a goal?
Yeah, you wanna be as low as possible, right? Aim for that point 0.6 and you wanna sustain that. So that's the lowest you could go was point 0.6 biological years for every one chronological year. Um, I like, you can retest the Dunedin pace every 8 to 12 weeks. It's so precise, that it actually allows you to do that. And the one thing we see change it, that actually the paper was just published in Nature about 2.5 weeks ago, is going to be caloric restriction. So about 10% overall caloric restriction. This study was done in healthy non-obese adults over a 2-year period, and it's called the calorie randomized control trial. So the Dunedin pace is still so new. We're learning about what actually reverses it and changes it. This was the first ever proof of concept study really showing the Dunedin pace can capture that change before and after, which is super exciting.
Wow, that's interesting. So just calorie restriction generally, not like intermittent fasting or fasting, or just totally just taking your calories from where you are, reducing them by 10%.
Exactly. I always say there's ways you can perform caloric restriction, like the time restricted feeding or intermittent fasting, because if you're shortening your window a lot, you're probably not taking in as many calories, but you could count just to make sure or understand that you're not taking in as many, or even like the 5-day fasting mimicking diet by Walter Longo as well.
Huh. Well, that's good news for you, Russ, because you like the fasting.
Yeah, I do like the intermittent fasting. I try to do it at least one Monday a month. I was doing 2 Mondays a month, and I just felt like I don't know. I just kind of lost pattern, but I do like it because it's a good reset, and my stomach is a little sensitive as well. So I like to kind of like figure out what is it that's actually driving my stomach crazy this week. So I'm able to kind of at least diagnose that. So our goal is to get down below the one. So we're both below the one. So that's a good territory, but getting to point 0.6 is a good measurable for us to try to aim for. So maybe when we do this at the end of our season, Sarah, we're see how close we get to point 0.6. Okay.
Yeah, we want to at least be lower than when we started.
Yeah, exactly, lower than your baseline, and that's Sarah, you mentioned Brian Johnson, his entire philosophy is we have, the Rejuvenation Olympics, if you've seen that, where people are submitting their Dunedin pace data and, comparing themselves against everyone else who's tested. So Brian was number 1. We're actually updating the list here soon, with people who've now taken the test, and it'll jumble kind of the epigenetic leaderboard, we call it. So yeah, maybe strive to get on that top list.
I think I'm ready to take on Brian Johnson.
Do it. I wanna see it.
Not that I'm competitive at all, but I don't like to be at the bottom of the list. I want to be at the top of the list. So Sarah, I will note that I'm going to go after Brian. I'm coming after Brian.
So what is Brian's values?
His is so it's not necessarily about the value, it's how you compare your value to people of your same chronological age. So he has the youngest before and after test with his Dunedin. But I think I mean, his is still super low. It's like 0.60 basically. It's at the, the edge of the algorithm, the lowest you could go.
Yeah, he has a super calorie restricted diet, though. I was reading that in the paper the other day. I mean, yeah, that's next level. He kind of puts everything in a blender and puts chocolate on top, and that's it, you know. But we'll think about that, and definitely, yeah, I think that's to reduce calories by 10% for a few months. That's doable. So let's go on to these intrinsic and extrinsic ages that you've got for us, because this is quite interesting for Russ and I, because Russ has got a low extrinsic age, but a high intrinsic, and for me, the other way round. So my intrinsic age is 32 and Russ is 57, which is quite a difference. Look at Russ.
Yeah.
Russ.
Let me start with intrinsic. Let's start there. But let me back up again. So, intrinsic and extrinsic, when you're talking about aging from this philosophical standpoint, we're aging in a lot of different ways, right? We have all of these different cell types. You actually have 28 million different methylation markers in every single cell type in the body. All right. So you have all these, imagine in your mind you can paint this image of all of these clocks ticking in your body, right? At different rates. So by definition, the intrinsic and extrinsic, when we're grouping them together, they are what I like to call a historical based aging process. So, how have you been aging? Not even since you were born, since your inception, you're aging even before you're born. So, since your inception up until now. So, it's capturing everything in between, right? When we focus on the intrinsic, however, the intrinsic is going to be this baseline fundamental biological age. So it's going to be this pure aging signal. So, Sarah and Russ, if anyone says, what is your biological age? Very generalized statement without differentiating, you would want to give them that intrinsic epigenetic age. It's more of this multi tissue clock. It's going to perform well in almost every single cell type, every single tissue type, too. So, it's kind of this overarching age. So, Sarah, I know you mentioned you're younger. That's great, right? That's where we want to be. Russ, I know you mentioned you're a little bit older, and that's okay. Um, a couple things to check in where you fall when you look at the population level graph, because a lot of people, I would say, normally are older intrinsically. We usually don't make the best decisions in our youth, right? As it relates to our health. So, what that is telling me, Russ, is that something may have happened across your lifetime that may have caused those clocks to tick a little bit quicker. But now, again, they're slowing down because that Dunedin looks really good, right? So, I want to put emphasis on that again. The longer and lower you can keep that Dunedin pace, the more you should see that intrinsic epigenetic age go down as well.
It's interesting because I did go through in my 20s. I had chemotherapy and radiation. I had cancer. And so that probably could be a little bit of a traumatic effect, especially the amount of radiation I had. So that's interesting to see that it's there. I mean, that would be the one. I mean, outside of all the stress and trauma of work and everything else, but that definitely plays a part then in your intrinsic age, then I imagine.
Definitely. I mean, we know epidemiologically what is correlated and what makes those clocks actually accelerate. Any type of disease diagnosis or outwards projection, phenotype, cancers, etc., are going to increase those clocks, right? So if you Google epigenetics and chemotherapy or cancer, I mean, you'll just see a plethora of papers written out looking at aging, looking at individual sites, looking at specific methylation. So we do see that would absolutely accelerate the clock. Mhm.
All right. All right. I've got some work to do. Let's keep slowing it down. All right.
I seem to have got away with a bit of a misspent youth.
Yes, Sarah, what were you doing? I mean, were you just living in caves and who knows, drinking milk and being it's your proper English upbringing is what it is.
Hey,
Yeah,
yeah, it
you would
might
think I would
be.
be 100 with the English upbringing.
I know how many concerts you went to and where you hang out. I know Camden Lock. You sent me there, so I know. But still, that's pretty impressive that Sarah's 32. I mean, that's like
Yeah.
incredible.
Yeah, that's probably one of the youngest I've seen in a while. I saw someone who was maybe 14 years younger a couple weeks ago, but it is rare, right? And I mean, with my position at TruDiagnostic, I onboard every single healthcare provider, we have. I do a report reviews with every single person who tests with us that wants to talk to me, of course. So I'm seeing it all, right? So that is super impressive and something you should be really proud of, Sarah. So keep it up.
And how reproducible are those results? How confident, like, if I was to test tomorrow, would I get exactly the same number for that?
Yeah. So again, asking about the precision of these algorithms, which is great. Everyone should be asking this question. It's super important. So how we measure the precision of these algorithms with epigenetics is an ICC value. And this is called an intra-class correlation value, basically meaning if you took two samples at the exact same time, how highly correlated are they to one another? And in a perfect sealed vacuum world, they should be exactly the same. We know that doesn't happen, right? Depending on, I don't know, who like touched it last or who shipped it, right? So what that means is there's going to be a teeny bit of variance just because again how the world functions. True diagnostic is going to we're going to pride ourselves in only using algorithms that have an ICC value of 0.96 or higher, and that is actually considered excellent. A lot of those older original epigenetic age clocks created back in 2011 and 2013 and even some newer ones today, they have you'll find the majority of them having ICC values of about zero point 0.6, which is okay, it's a starting point, right? We have to start with those in order to increase that ICC value, but we'll only offer any algorithms that have an ICC value of about 0.96 or higher.
It's interesting. In a previous life, I was a research scientist in a drug company, and so I know how difficult it is to get that degree of reproducibility. And I was looking at some of the data that people have put up because a lot of the biohackers, put up these measures and they're making quite radical changes to their health and lifestyle based solely on one test. So I was kind of wondering, how can you kind of guarantee that? But you're right, if you're getting something at 0.96, then that's cool. And presumably people have actually tested this now and done repeat tests, without changing anything over and over again, and you've kind of validated that that is the case.
Yeah, definitely. I think we'll learn more as hopefully more research trials are published and posted. Right, the stuff is forever changing. So yeah, we'll see what they come up with, and I can talk about some of the future developments later as well.
Cool. Okay, so let's go on to the extrinsic because this, Russ,
Yeah.
is where you're younger.
This is where I won. This is where I beat you.
This is where
So
you
you're
win.
how many years younger, Russ?
So I'm 49.75 and Russ is 46.33.
Perfect. So the extrinsic epigenetic age is going to be different. It's actually what we call the age of your immune system. So the extrinsic epigenetic age is looking at how your immune cell subsets are changing as you become older chronologically. And remember, that's super important because we know these immune cell subsets are going to change. We get more senescent T cells as we become older. We get less differentiated cells, and then we get even more natural killer cells, which is great, but those are going to become less effective as we age. So it doesn't really matter. So, right, these immune cell subsets are always changing, and we need a way to account for those changes. So, that is what the extrinsic epigenetic age algorithm is capturing. Most people are typically going to run a little bit younger here. Um, and you all are so young. I think Sarah, you said you're only 49 years old chronologically. Russ, you're 51. So I would expect your immune systems to look pretty good, right? Unless there was some type of disease diagnosis or phenotype going on, unless those immune cell subsets started to go awry. So typically the nature of this algorithm, the extrinsic epigenetic age, does tend to run a little bit younger in people.
That's interesting because I had a lymphoma, which is my lymphatic system, which is where my cancer was. So I would expect to see that my age would match what my age and my intrinsic was here. So that's good to know. I'm wondering too of like, with all the stuff that's been going on with, and I hate to bring this up, but do you see anything with the vaccination or anything that like would show anything different here in terms of like proteins and vaccinations or anything there, or is it mainly just what your body is and how your body reacts to to the outside world?
Yeah, great question. Everything is going to affect it, right? So, the cancer. or you said your lymphoma, Russ, could have affected the extrinsic epigenetic age, but it could have been corrected, right? But it could still have a lasting effect on the intrinsic. So these things are going to affect these algorithms in all different ways. Actually, the first study TruDiagnostic published was with Cornell, looking at in Frontier. So it was a great paper, and it was looking at DNA methylation markers longitudinally uh, before COVID-19 diagnosis and after COVID-19 diagnosis. And we actually looked at the mRNA vaccines as well. So there was a really fine line drawn in the sand. People who were over 50 and had COVID-19, they actually would have increased epigenetic ages as a generalized statement, and people who were under 50 who were diagnosed with COVID-19 would have lower epigenetic ages afterwards. And very introductory study, right? But however, we think it's probably because of an immune system response, right? The younger could respond. The people who were 50 or older maybe couldn't respond as well. So it's interesting. I can send you that link if anyone's listening and they're interested.
Yeah, that's great. And I will say I got my first COVID when I was 49 years old. So I was right at the cusp. But anyhow, I just got it again last week for some reason, but it was actually a very mild version of it. I think that's really interesting and such an important thing to look at. Now, are there things that you can do to impact the epigenetic score? Because that's, I think, the
Oh,
area where Sarah and I are like, okay, what are we gonna do to make our immune system stronger?
yeah. All sorts of things. When you're pointing to the immune system, think of immune modulation therapy, right off the bat. So definitely your vitamin D. That's my number one recommendation. It's been really well validated in the literature in terms of interventional trials, about 4,000 to 6,000 IU per day. Um, of course, you could go your zinc route too. You could do different IV cocktails, right? Like the vitamin C, the glutathione. You go into these clinics and they have kind of this immune IV offering. So that would be really nice. If you want to, dabble in more of the like pharmaceutical and medication based worlds, you could do, there are some different peptides out there, like the thymosin alpha 1 immune modulation peptide to help regulate the immune system. And there's also growth hormone secretagogues as well that would help regenerate the thymus for better immune system thymic aging. And to name some of those, that would be like your CJC 1295 and ipamorelin or your samorelin. There's always new growth hormone secretagogues on the market. So if you're still lucky to be able to access those peptides, those could be some further options as well.
Super helpful.
Yeah, great. We've got an episode on peptides. We'll have to go back and revisit that.
Yeah.
Um, we have to see. I think there's a big difference. There's no clinics here offering IVs in rural Dorset where I am, but certainly
There
we
are where
also
I
have.
live. Yeah, where I live, I'm at. My wife and I have like we actually during COVID we both got COVID at the same time. They had someone come to our house and do some IVs. We did the same thing with my father-in-law as well, and it was helpful. I mean, it like sparked me up. I felt great for a few hours, but then I went back to bed and dealt with my COVID.
Very California. That's great though. That definitely gives us some pointers, and we will go back. It was Natalie Niddon we had on in
Yeah.
our last season, so we can go through and look at those peptides. That's
Yeah, I
cool.
love
So let's
Natalie.
you like Natalie? Yeah, she's great, isn't she? Let's talk about telomere length too, because that's certainly something in the press. People are talking about these telomeres, which is the end of the chromosomes, right? Which is now a gauge of how you're doing because
Yeah,
you
yeah,
don't want them to
definitely.
unravel or
I would say telomeres are our least favorite output. You know, they've been studied for a long time. My theory is they've been studied so long because we still don't know what the heck they do. Um, but they used to be the golden standard for biological age-based testing until this epigenetic methylation really took over. So we're still interpreting them, but from an epigenetic methylation standpoint. Now, the reason I say this is going to be backed by literature. They only make up about 2% of the entire phenotypic aging process, so just a very, very small amount. However, they are one of now like the 12 or 13 many hallmarks of aging we have, so we know they're still important. We just need to know how to interpret them and use them clinically, right? Because knowing the lengths of your telomeres, if I just said my telomeres are 7.1 kilobases, that's cool, right? There's not much you can actually understand from that. So what we want to do,
Hannah, I'm shocked. I can't believe your kilometers are that long.
yeah, no, yeah, like it doesn't mean I don't know anything. But that is like an okay length, I would say. So we want to compared to the population. So we want to make sure you're at least in the 20th percentile or higher. So Sarah, I don't know, looking at you and Russ's results, hopefully you're in the 20th percentile or higher. If you're not, that's okay, but we can fix it. That would just mean that you have more senescent cells at the time you took this test. So what you want to do with that then is you want to come in with a senolytic, right? Like the fisetin, quercetin, pterostilbene, curcumin, resveratrol. I probably missed one in there somewhere. But what that senolytic treatment is doing is it's clearing out your senescent cells. Those senescent cells have shorter telomere lengths in them. So you're clearing out the shorter telomeres as well, and then you're artificially bumping up your average telomere length. So it's not like you're magically making your telomeres longer, it's just you're getting rid of the shorter ones.
Right, that makes sense. I mean, when you go to these biohacking events or longevity events, there are people with booths, and that is all that they're doing, is they're offering you a test for your telomeres. So it's something that I've looked at for a while. Like, I wonder, and you kind of think that it's giving you an average length of your telomeres in all your cells. But what you're saying is some of these cells, the senescent cells, or the ones that the body's looking to get rid of, have got shorter ones. So really what you're doing, you're not extending the length of your telomeres, you're just reducing those cells in your body that really shouldn't be there. So we've got 7.24 and 7.03.
That sounds pretty good. Yeah, if you look at hopefully you're in the 20th percentile or higher in both of those, and I'm sure you are for your chronological age because those are I would say that's pretty long being around 7. So yeah, that would look great, right? And, another thing to maybe clear up as well is there's a lot of ways to measure telomeres, right? There's a lot of companies like you mentioned, Sarah, you'll see at these conferences. Um, we do it again through epigenetic methylation, and that's actually going to have a 2.5 times correlation to age outcomes than quantitative PCR processing. So, we'll replace or be even better than that quantitative PCR, but we will never ever be as good as the fluorescent in situ hybridization method, or what they call FISH, where they're like going in and actually counting the kilobases. But again, I would just challenge people who are using that. What clinical value does that add to you?
For sure. So I think we've kind of gone. They're the most important scores that you would have from the report, because the report's quite intensive. I mean, I think we got like 4 or 5 pages of different scores. Um, we got things like, the only other different one that Russ and I had was our epitype, where I was a non-responder and Russ was a responder. And I think actually was this to the maybe even to the calorie restrictive diet. I'm hoping, because
Yeah,
I
yeah, it
don't want to
was.
do it.
Yeah, so we have a report that is basically telling you, are you gonna lose weight from caloric restriction? So we love caloric restriction, as I mentioned, as a therapy for longevity, but some people use it as a weight loss strategy, right? And not everyone's gonna lose weight from it. So, we can tell you if you're going to or not. So, Sarah, I think you said you're a non-responder. So we'd still recommend caloric restriction to help your denindin, but you just would not lose weight from it. And then I think you said Russ was intermediate or
Responder.
full. Okay, full responder. So Russ, you know, if you do perform caloric restriction, you would lose weight. Again, that may be a good thing, that may be a bad thing. It kind of just depends if someone wants to lose weight or not and what they want that journey to look like.
But my caloric addition means I put it right back on, which is what happens every single time. And it is interesting. I was looking at our telomere, and you had mentioned, I want to go back real quick. I'm sorry. You said that percentile wise, we wanted to be in which percentile?
The higher the better,
Okay.
right? But you don't want to be, I would say the danger zone is like the 20th percentile or lower.
Yeah, I'm in 34th, but my telomere age was 54. It was 54, so a little better. But so this, I just so I understand on the telomere, because if it is something that lots of people are talking about and it's sort of a new trend, um, what does it mean? Like, what I didn't actually gather, like, what does it actually mean if my telomere is shorter or longer?
Yeah, so like Sarah was kind of alluding to, your telomeres are going to be these caps of your chromosomes, keeping your DNA nice and tight together and coiled. As you age, think of it like a shoelace that like frays at the end, right? It becomes dysfunctioned, and then your cells start sending signals to the wrong cells, and it's like a madhouse in your cell. So these telomeres are actually going to degrade naturally as we become older chronologically. Um, and It's inherited basically mostly from our parental side, so we get the length of our telomere mostly from our dad, and then have
Definitely
a
from my dad. My short telomeres are from my
Tele
dad. I will claim that forever.
That's funny that you say that. But you also get a percentage of that degradation each year, right? So people may degrade slower or quicker depending on, lifestyle factors, a bunch of different things. But it's just a correlation, right? It's not necessarily a causation. That's not why we age. So they do become shorter with different diseases or aging, but it's this is also a big discussion in the space. Can we actually elongate telomeres? And I think the answer is no. There's no therapy I know out there that you can take. There's no magic pill that again says, poof, your telomeres are longer, right? It's about clearing those senescent cells, those zombie cells that are causing junk inflammation, oxidative stress in your body to keep the longer ones around.
That makes sense.
Yeah, and it's not really an indication of age then, is it really, your telomere length? Because
Correct. Yeah. I don't even
you've
really
got
like
what
to
you've
look
got.
at the
Yeah.
biological age
Mm.
based on your telomeres. I mean, you can, but that's just kind of like we're plotting you and using a little, y equals mx plus b formula. Probably haven't heard that since, college, but to plot you and then give you a biological age based on your telomeres.
Yeah, and it's Hannah. I think the interesting part here about quantifying us to this level is that this is a moment in time. We took this at a moment in time, and we could have been going through things. And I imagine it's important to retest and to track. Maybe it's an annual thing. Maybe it's something you do every other. Every 6 months. But how often do you suggest you do this? Because taking this and saying, I'm going to build everything off of this one test in this one moment of time where I could have been, I could have had a huge meal the night before. I could have gone out with Tony Soprano and had, white wine and scallops and or I didn't sleep well that night. So like how important is it for us to sort of retest to make sure we're seeing kind of, behavioral changes and we're seeing some of the things in it that are going to help us improve?
Yeah, that's my number one question I get at conferences. "Hey, I just partied with a ton of friends and drank a lot of booze, right? Is that gonna affect my score?" The answer is no, right? It has to be a habitual routine to actually have an effect. So that's, the simple answer. And disclaimer, I think you need to look at many biomarkers according to your health, right? I'm very biased toward epigenetic methylation testing. I think it's the future, obviously, right? But I think you still need to look at a multitude of different things. With our full panel, the one that you all did, I'd probably say you could do it as soon as every 6 months, but I say like 9 to 12 months, maybe, just because you want to give yourself enough time. You need to hold yourself accountable to actually make those changes. But that Dunedin pace, we offer a smaller kit called TruAge Pace that just does the Dunedin and the telomere length report, and it's cheaper as well. So you could retest that every 8 to 12 weeks if you wanted to.
It's a good segue, Hannah. So, where can our audience find your test? I know it's True Diagnostic, but can you give everyone kind of the location of all this and sort of where to start?
Yeah, definitely. So you can find both of the kit options at TruDiagnostic.com. It's TRU, not an E at the end, and then diagnostic is singular. So we have that True Age complete collection. It includes everything. So Sarah and Russ, everything you all have been chatting about with me today. And then the True Age Pace is going to be a little cheaper, only including that Dunedin and telomere. Really good for quick follow up, trying to biohack your way through everything you're trying. So you can find those two products on our website. The kit, the process is basically the same where you're pricking your finger, sending it back to our lab, and then we'll get reports out to you in about 2 to 3 weeks.
Yeah, and the reports are amazing. I went through them when we first got everything back, and it's really an incredible test. And grateful I did it, and now I know, and so now there's something to aim for. If there was one takeaway and one tip that you would give on on really, I think the intrinsic one is probably the one that I would look at and say, in your Dunedin, but like I think those two things, what would be your thing that you would say, let's start there?
Yeah. And Russ, I love that you said, and now I know, right? A lot of people think they're very healthy, but you really can't tell how you're aging until you objectively test this. So my number one, the recommendation for this, and I'm probably biased because this really affects me, but it has great literature backing too, is going to be stress. Reduce your stress load. that has a huge effect on intrinsic, extrinsic, denindin, telomere, everything. So if you practice meditation, you do breathing exercise, I mean, whatever does it for you, reading, writing, singing in the shower, right? Really try to reduce those stress loads.
Yeah, that's interesting because we don't talk so much about that from a biohacking, and certainly if you look at like these Brian Johnsons and Dr. Hyman, it's just a list of diet and a list of supplements and maybe a high intensity exercise regime. It's not so much a focus on stress. And actually, we were talking. We've got another guest. I think he's coming out next week or week after Freddie Set Go, who talks about emotional regulation and how you need to control stress. And I actually am coming round to think that that is probably the most important thing for health. Be- because if you don't have a handle on that, the diet not necessarily going to have any effect because you're not digesting anything or you're not moving properly if you're all caught up with stress. So I think it's easier said than done, though, but certainly something to work on.
You've heard the term, stress eating even, right? You're
Yeah, of
stress eating,
course.
you're indulging, so it's linked. So yeah, that's a good point. It's just kind of connected in all your facets of life. So, and it's hard for us over here in the States, right? It's like 9 to 5, 60-hour work a week, right? Grind, grind, grind. We're not taught to like relax and breathe and, enjoy, take it in. So it's kind of beating the social aspect of it too.
Yeah, it's something that I will say I have put a lot of energy into cutting down the stress and everything from being a super commuter to being a single dad, a divorce. I mean, everything just sort of it compounds, and it was just like I look back and say 30s and 40s, it was all one big blur of stress. And I think now, having met Sarah and having done this now for 4 years with her, really that focus of stress. And Hannah, I'm really glad you said it because it is so important because that's where it starts. Because if you're stressed, you're not like my wife does not eat when she's stressed, and like I'm like you need to eat something. And for me, when I'm stressed, I just go eat. I eat her food, so then I double up. Um, but it is
Perfect
important.
couple, right?
Yeah, we're a perfect couple. She like she bulks me up like I'm her bear. Um, Hannah, you had mentioned right before we started this episode that you just launched your podcast. What's the name of it? Where can we find it?
Yeah, my the name of my podcast is called Everything Epigenetics. So you can find that, on all streaming platforms, YouTube, Spotify, Apple. Go to everythingepigenetics.com. But my first episode is actually with Dr. Terry Moffat, who is really the lead investigator on that Deneen Pace algorithm I mentioned. So she's just lovely. She is our collaborator at Duke, and I'm just very lucky to even have known her as a person.
Fabulous. Well, we'll be checking it out and checking in, and maybe we'll speak to you again at the end of our 6 month longevity trial. But thank you so much for coming on and for all the tips and for explaining all that data. It's super interesting. Really appreciate that, Hannah. Thank you.
Yeah, thanks, Sarah. Thanks, Russ. I appreciate it.
Thank you. Take care. Bye bye.
Breaking the gray.